I think most people are unaware that there's weather in space. I think we look up at the night sky and we usually just see darkness punctuated by starlight. But often, especially if we live in the more northern parts of the world, we'll see the aurora. So now we know that the aurora is particles from the sun called the solar wind, or originating from something called a solar storm, crashing down. So these are invisible particles crashing down into Earth's atmosphere and emitting these light waves that we see. So, people come up to me and ask me, they're like, space weather? Why should I care about space weather? I live on Earth. What does this have to do with me? And the answer is a lot, actually. We rely on technological systems that are heavily dependent on the space environment. And so what I'm talking about here is GPS, radio communications, and actually even electricity. The biggest solar storm to ever happen was in 1859. It's called the Carrington Storm. And actually during this storm, the aurora was seen as far south as Panama, Central America. So it was really more like the central lights than the northern or southern lights in this case. So what happened was actually the telegraph wires were completely overloaded with electricity, and actually the operators were shocked trying to use it. But of course this wasn't as bad. If a storm were to happen of this magnitude today, we would actually lose power. We could lose almost the entire North American power grid for months. And estimates are in the trillions of how much this would cost. So it would actually be the most costly natural disaster in history. There's more than one type of solar storm, but the one that we're probably most concerned with is our solar flares and coronal mass ejections. Now, a coronal mass ejection is a massive explosion of the fourth state of matter called plasma, which is something kind of like a hot gas, and it explodes off the sun, and it travels at speeds 10 times faster than lightning. So it's incredibly fast, and what happens is it just slams up against the Earth. And the Earth has a magnetic field to protect it, much like a bar magnet on your fridge. And what happens is these particles can stream down from the sun into the atmosphere, and that's how we get the aurora. Here at Michigan, this is why we are interested in studying these and understanding these storms and how they affect the near-Earth space environment and how we can predict and forecast them. And so this is what we do, because actually you can mitigate the effects of these storms if you know they're coming and you know how big they're going to be. You can do things like put a satellite in what's called safe mode. We can lighten the load on our electrical grids so that the surplus of electricity will not blow out our transformers. There's a number of things we can do to sort of make sure that we aren't left vulnerable to solar storms. And so what we do here at Michigan is we develop computer models to try and predict when and where and how much of a problem these storms could be in which areas of the globe. And so we're working towards this. It's a very difficult task, and so it's really important, but also really fun research.